Right, today we're going to talk about finding perimeter on a coordinate plane. So this is just basically using distance formula to help us figure out how long every side is, right? Perimeter means finding the distance around a figure on the outside. So on page 49 in your books, there's an example. It's an example 2. We're going to talk about this example. We need to find the perimeter of DEF. So the easiest side that you can start with is this horizontal side here, and you're just counting the spaces, right? To get from here to here, we're going 4 spaces to get to the axis, and then 4 more spaces. So it's a total of 8. So this distance is 8. And then these are slanted. When they're slanted, you're going to have to either do distance formula or Pythagorean theorem. So think about if you made a little triangle out of this distance here would be 3, and then this distance here would be 6. So I could do Pythagorean theorem for that, and I'd be doing 3 squared plus 6 squared equals c squared. And then I'd have 9 plus 36, so that would give me 45 is c squared, and I'd be taking the square root of 45 for c, which is the same work that they did over here, but with the distance formula. So either way you get the same answer, just depends which method you like. Okay. For the other one, we can make a triangle going like this. And we can do the distance. Here is 5, and this distance is 6. And then we'd be doing Pythagorean theorem for that, where we'd be doing 5 squared plus 6 squared equals c squared, and we'd have 25 plus 36, add that up to get 61, and then take the square root of 61. So same thing that they did right here, where they found that same distance and they did the distance formula. So either way works, right? And then our goal is just add up everything. So you can see down here, they just added up the 3 things. You're going to have to use your calculator to get estimations for these and add them up. Okay, we're going to do 2 more examples. When you turn the page, in the gray box on page 50, at the top we have problem 5 and problem 6. There's not really a lot of space here and there's no graph. So we're going to do this on graph paper. So you want to get yourself a piece of graph paper and you're going to plot these points. Okay. So you might need to pause the video and plot your points. Right, we've got G, H, and J plotted on this graph. Okay, if we go ahead and connect these, you always want to start by looking for is there an easy side that runs either horizontal or vertical. So right now we've got this side that runs horizontal, 1, 2, 3, 4, 5 units. That's the easy one. So we're going to write off to the side GH is 5. And then we can make triangles with our other sides to do the Pythagorean theorem, because that's a little bit easier than doing our distance formula. This side is 3, 1, 2, 3, 4, 5. This side is 5. So we're going to do 3 squared plus 5 squared equals c squared. And we get 9 plus 25. 9 plus 25 gives me 34, so the square root of 34 is c. Okay, then on our other side, we can make a triangle over here, like this. This distance is 2, and this distance is 5, so we're going to do our Pythagorean theorem again. 2 squared plus 5 squared equals c squared, and we've got 4 and 25, which gives me 29. So this is the square root of 29. So now I've got 3 sides. So I'm going to write these down over here. HJ was the square root of 34, and GJ was the square root of 29. And this is what I need to add up. So I'm going to have to round. I'm going to have to take the square root of 34. That's going to round to 5.83. I'm going to have to take the square root of 29, which is going to round to 5.39, and then I would add up our 3 numbers to get the total perimeter. and it's of the whole triangle GHJ, and we're going to add up 5.39, 5.83, and 5. We get 16.22. All right, I'm going to stop the video here and start another one for this next example.